Hello everybody in Algebra 2 Advanced. This video is going to be the lesson that goes with chapter 1.2 of your textbook. Before I go any farther, let me say two things. First of all, referring to the textbook, I'm going to assume that every time I make one of these videos, you're also going to read the section of the textbook that goes with that video. I'm not going to cover everything that's in the text. I'm going to assume that you read it. In order to do well on the quizzes, the exams of this class, in order to understand the material of Algebra 2 well, you both have to watch these videos. You have to understand the lessons that I present, as well as read the textbook itself. I may not remember to say this every time, but I'm going to assume every time that you're going to have read the material too. Second thing, notice that in this case, this is a review from Algebra 1, from the material that you learned 2 years ago. All of Chapter 1, and much of Chapter 2, in fact, is review material for you. I'm going to go fairly quickly, as a result, through that material, trying to get us as soon as I can to Chapter 3, where we begin some material that's going to feel newer to you. Chapter 1.2 is going to consist of 6 things that I really want you to make sure that you know. This video, unfortunately, will probably have to be broken into 2 parts. 6 things is a lot to cover, even though I'm trying to go quickly. First thing, vocabulary. In the interest of trying to be quick, I'll talk about the vocabulary in the context of these other things down here, rather than separately talking about the vocabulary and then getting into these things. Second thing, evaluating powers. Evaluating, well, it is one of our vocabulary terms. Powers, working with exponents. Third, order of operations. PEMDAS is probably a term that's familiar to you. I've got to make sure that you understand how to work with order of operations. It's a basic building block for the rest of the year. 4, evaluating algebraic expressions. Of course, this also is a basic building block for the remainder of the year. Combining like terms is certainly something that you should have learned in Algebra 1, but I've got to remind you how that works. And then lastly, we're going to apply all of this and talk about how to use algebra in real life. All right, let's get going. As I said, the vocabulary I'm going to talk about in the context of the next few things. I'll just highlight right now the fact that often I find, having taught Algebra 1 as well as Algebra 2, that students get these 2 concepts confused with each other. Similarly, they often get expression and equation confused, and I'll try to make sure that I've kind of teased out for you what the differences between those 2 things are. Let's get to simplifying and evaluating powers. Again, powers, remember we're talking about exponents here. Simplifying. Well, here's a perfect example of why I would want to simplify. Here I've got a string of 5a's being multiplied. Not too terribly cumbersome to have to write, but imagine if instead of 5 it had been 55, or 555 a's in a row. The whole reason that we use exponents in the first place is simply as a shorthand to save us trouble and time. It's a matter of simplifying. So this first one here, simplified, becomes a to the 5th. Likewise over here, notice that actually what I have is a string of 4 negative 9s. And all of them are in parens. So I'm going to keep those parens, and I'm simply going to apply the exponent to the whole thing here. Keep in mind, that means then the exponent goes to what it's next to. It goes to everything it's next to. So I not only have 4 9s, but I also have 4 negatives. That'll become important in a second. The 2 y's, well in this case I have 3 sets. Simplified, I keep the parens and I give that exponent to it, so now I have 2y in parens to the 3rd. Notice that the 7 wasn't in the parens before, and it doesn't belong in the parens now because I'm not applying any kind of exponent to the 7. I only have one of those 7's. What I'm saying with this 3 is that I have 3 of these 2y things. All right, your turn. I'm going to give you 3, and I'm going to ask you to simplify them. Those are the 3, so go ahead, look at those, and when you're ready, hit the pause button and try to simplify them yourself. Okay, I'm going to assume that you did hit the pause button, and now I'm going to just show you the answers and talk through them very quickly. I hope my handwriting is legible. That's supposed to be negative x in parens to the 3rd. That's 4b in parens squared, because I have 2 of them, plus, or and, 2a in parens, also squared, because again I have 2 of them. And this is supposed to be an 8 with an exponent that's an n. 8 to the nth power can be written more simply in that fashion. By contrast, evaluating means that I'm actually coming up with a value for the thing, the expression that I'd had. Each of these things up here is an expression. It's not an equation. There is no equal sign, so there is no equation involved. The equation happens when I say that one thing is equal to another. And in the process of evaluating, I am going to end up creating equations. So let's look at some things that I'm going to evaluate. I'm going to try to figure out what the numerical value of this expression is, and then this one, and so on down the line. Well, let's just get right to it. The numerical value of the first one is positive 81. Why? Because, as I said, the 2 goes to everything it's next to, and in this case, it goes not only to the 9, but also to the negative. If I multiply 2 negatives, I end up with a positive. My answer becomes positive 81. In this case, the 2 is only applicable to what it's next to, which is the 9. So I've got 81 here, but I've got a negative that I haven't done anything with. So my answer is negative 81. In this case, the 3 does go to everything it's next to, but I've got an odd number of negatives. Negative times negative times negative remains a negative. And then 2 times 2 times 2 is 8, so my answer is negative 8. In this case, I've got the exact same expression here with an additional negative sign stuck outside to the left. Let's ignore that for now, because after all, the exponent has to be dealt with first. So I've got negative 2 times negative 2 times negative 2 again, which again, like over here, was negative 8, but I've got this negative I haven't done anything with yet. Negative negative 8 is positive 8. All right, your turn. Here are a few that I'd like you to evaluate. When you're ready, go ahead, hit the pause button. Okay, again, I'm going to assume that you've done that, and here are the answers. Don't hesitate to come into class with questions, if you have any, about these answers. If you're having trouble reading my writing, that's supposed to say equals 81, equals 64, equals 32. Notice that in each of these cases, I've come up with an equation. This is equal to that, that's an equation. But this up here, no equal sign, that's an expression. PEMDAS. I wish when we taught PEMDAS that we presented it first this way. And here's why. P for parentheses does come first, and E for exponents does come second. But the M and the D, they have equal priority in the order of operations. It depends on which one is furthest to the left in the expression that you're dealing with. If the division operation came before multiplication, you would actually do division first. Same thing here with addition and subtraction. The 2 of them come last, but subtraction can come before addition if there's a subtraction operation on the left and then an addition operation on the right. We'll try some problems that illustrate that later, but first I want to just make sure that we've gotten a couple of other concepts about powers straight. Negative 4 to the 3rd power versus the same thing with the negative 4 in the parens. These two things are actually going to turn out to have the same result, but for different reasons. In this case, I'm doing 4 times 4 times 4, then I'm applying a negative, so this is negative 64. In this case, I'm doing negative 4 times negative 4 times negative 4. That's also negative 64 as it turns out, but that's because there are 3 negatives. An odd number, in other words. Let's look at this one. 3x squared, in this case the 2 only applies to the x, whereas in this case the 2 exponent applies to everything that's in the parens. Let's think about substituting a number in. Something simple. How about if we just made that 2? Well, PEMDAS says the first thing I deal with is the exponents. 2 squared is 4, and then 4 times 3 is 12. So this is evaluated would be 12. Evaluating this though, I'd have to do the 2 times the 3 first. I have to do what's in the parens first. 2 times 3 is 6. 6 squared is 36. So again, when you evaluate these two, this becomes 36, whereas that was only 12. Let's try something a little harder here. All right, again, I've got to do what's in parens first, but within the parens I've got a couple of operations. I've got to do 4 squared, and then I've got to add 8. Well, 4 squared is 16. And 16 plus 8 is 24. So what I really have here is 3 times 24 divided by 4. Remember, now what I have left is multiplication and division as my only operations, and the one on the left comes first. So I do 3 times 24. Sorry to be doing this in my head, but I got to tell you, writing with the pen on this tool is really difficult. 3 times 24 is 72, and then I do 72 divided by 4, and I get 18. Now what I'd like you to do is try these three problems. Notice the only difference is where the parens appear. But you're going to get, I think you'll find, different answers. When you're ready, hit the pause button and give these a try, and in a second I'll show you the results. Okay, the first one, you should have come up with 50. The second one, you should have come up with 54. Any questions? Don't hesitate to come and ask me. Let's move on to number 4, and this is probably the last topic that we'll cover in this video, and then we'll continue on in a second one. Negative 3x squared minus 5x plus 7 when x equals negative 2. Well, first thing to do is simply to substitute that negative 2 in where we see x. Because it's a negative, I'm going to put parens around it wherever it appears. That way I'm going to remember that x is this whole thing, this whole negative 2, and not just the 2. So I do it here as well as here. Notice all I've done here is substituted negative 2 for x. All right, now it's simply a matter of figuring out what's negative 2 squared. That's the first thing that I would do, because there's not really anything I can do inside these parens. Yes, parens comes first in PEMDAS, but there's nothing I can do inside here. So the next operation in the order of PEMDAS is exponents. Negative 2 squared is 4. 4 times negative 3 is 12. So I've got negative 3 times 4 minus 5 times negative 2 plus 7. As I say, that's negative 12. That's going to become positive 10. Negative 12 and positive 10, and I don't have anything that I have to do yet with the 7 because addition and subtraction come last. Now it's just a matter of cleaning these up. And you should come out with the answer of 5 for this string of 3 terms. I'm going to give you guys one to work on as the last thing we'll do in this video. Hit the pause button, and when you're ready, I'll show the answers to these. Okay, I'm going to assume that you've done that. Notice that what you'd actually been asked to do was to put 3 in whenever you saw x and 1 in whenever you saw y. So here I've written those out. 3 times 3 plus 1, 2 times 3 minus 1. And likewise down here. Well, 3 times 3 plus 1 becomes 10 across the top. 2 times 3 minus 1 becomes 5. You should have come up with 2 as your answer. For the second one, I've already shown you here how to write these out by substituting in. And I think I'll move left to right. So on the top I've got 2 cubed. On the bottom I've got 2. And you should end up from there finding out that the answer, the result, is 4. I'm going to stop the video here, and I'm going to have to continue it with an extra video.